Okay, these are some types of questions can be asked from the Lloyd's mirror. So just geometry based, nothing is there. Okay. Okay, let's go for one more. Like if some questions like this of mirror comes, okay, can we work out? As now we have certain idea from the Lloyd's mirror. The same concept based on that, I'm taking this one. Okay, let me take the M1, M2 or two plane mirror. Okay, the M1 and M2 are two plane mirror. And S is monochromatic source. AB is a stop. Okay, what it do? It will block the light. It will not permit the direct light to reach the screen. So what all the light reaches, it will be only the reflected light. Means the light emitted by the source will fall on mirror M1. After reflection, it will reach you. So it'll be like this. Huh? Then similarly, the light emitted by the source will fall on mirror M2. After reflection, will fall on the screen. So what this AB will do, it will not permit the light to direct light to incident on a screen. So what we are doing, the AB is setup. It's like some opaque screen or something which will block the direct light reaching the screen. So we have like this. So here what is asking, which stops the AB is a stop, which stop the direct light to reach CF and allows the reflected light from M to reach CP. P is a point on CF such that SP is parallel to M1, M2 and perpendicular to CF. So he's asking to calculate the now the position. What happens to point P? Will it be maxima or minima? At what distance the point P will it be maxima or minima? That we have to calculate here. Means is asking now like if point P the max for point P to be maxima, what should be the wavelength of the light? Okay, this will be the question. For point P to be maxima, what should be the wavelength of the light? Okay, let's get into condition. So he has given the distance as D. Now, when a ray of light reflected by a denser medium, it will undergo a phase change of pi radian. Due to phase change of pi radian, it will gain additional path of how much? Lambda by 2. Okay, agree this? When a ray reflected by a mirror, it gains a path of lambda by 2. For point P to be maxima, what is the condition? So here, let's get into this one. The ray emitted by the sources will be incident on the mirror. It will have a zero phase. After reflection, it will acquire a phase of pi radian. Similarly, a ray emitted by source will come and strike the mirror. So what is the phase of this zero? After reflection, acquire a phase angle of pi, and it will reach the screen. Agree this one. So now, so this particular ray will appear as if it is emitted by the source S1. Similarly, this particular reflected ray, it will traverse the path as if it is emitted by the source S2. And from the ray optics, we know it like a object distance should be equal to image distance, D and D. What is the object distance from the sources from the mirror M2? 2D. Then image distance will be formed at distance 2D. So this S1, S2 will be like a coherent source of wavelength lambda. What is the distance between them total? Will become 6D. You see the total distance, this one. How much it is? It is equal to 6D, that one. Then the source is at a distance capital D. It is given here. Make observation. So what is the fringe width? Is equal to lambda capital D by D dash, where D dash is equal to 6D. Now, come for this one. Okay, for point to be maxima, what should be the wavelength of the light is telling. So let at what distance the point P is at a distance D, that what indicated in the diagram. You can see from here. Okay, let's get into this one. Okay, let me bring this. Now you can see things clearly. This distance will be 2D and this will be 4D, no, altogether. This distance will be 4D. And this distance is what? D. So what is the axis? Axis should be about axis, what means the sources should be lie symmetrically. So therefore 2D plus D, this will be 3D. And this will be a 3D, that one. So where is the point P lies now? At a distance D. So what is the condition for point P to be maxima? Y should be equal to n lambda capital D by 6D. So what is Y is equal to from the diagram? The question given, Y is equal to the point P at a distance D from this one. From the mirror, it is at a distance 2D and he has given this distance as D. So put Y is equal to D from the axis. Solve for lambda. Lambda equal to how much we'll get it? 6D square by ND. Put n equal to 1. If there's a first order maxima, there's a one wavelength. Put n equal to 2. There's another wavelength. Put n equal to 3.